So year 1 practice paper question number 1. See also section 44.3 in the textbook, page 444 in the old one, 427 in the new. This question is all about differentiating the formula and then finding the values of x and y at that point. So part A says differentiate the formula. So if y equals 12x cubed plus 3.6x, and differentiating this, dy by dx equals 36x squared plus 3.6. So that's the differential. Now part B says find the value of x when the differential is 0. So part B, 3x squared plus 3.6 equals 0. So what we do is we subtract 3.6 from both sides. Divide by 36. Which is minus 0.1. So now we need to find the square root of this. I've actually probably set a question that I would normally have made this more difficult, because this is going to be a complex solution, isn't it? So this is going to equal the square root of 0.1 j. And so what's the square root of 0.1? And then, well, that would be the answer, 0.1 j. .316 j. Part C says find the value of y at this point. So putting this back in to the original function, just using the value of x for this particular one, so 0.31, we could then work out 0.316, putting that back into this original function here. The original function here, we could then find it. So y equals 12 times 0.316 cubed plus 3.6 times 0.316. And that will give you y. So now we're looking at a situation where we've got the imaginary axis here being represented. So for part C, y equals 12 times 0.316 so that would be j squared plus 3.6 times 0.316 j, and that's going to give us 0.316 squared times j squared, which is minus 1, isn't it? Plus 3.6 times 0.316 j. So it's going to give us a complex number with a real and a complex solution. Not what I intended this question to do, actually. And we get y equals minus 1.2 plus 1.138 j. In the exam, I won't be giving you a complex solution. It could just be to do with finding the differential, finding the value of x when the differential is 0, and then finding the value of y at that point. So see some of those questions in section 44.3.